So now let's put some numbers to these. So you could actually measure someone's P wave, their PR interval, their QRS complex, and even their QT interval and know what's normal. Because if you know what's normal, then you can see what pathology might occur if they're outside these normal ranges. The P wave needs to be somewhere in between about 0.08 to 0.1 second. The PR interval, this is very important, needs to be between 0.12 and 0.2 seconds. The QRS complex we went through earlier, 0.06 to 0.1 seconds. And finally, the QT interval is a little bit more varied. The QT interval is very dependent upon someone's heart rate. So you measure your R to R interval, and that's part of the equation to calculate what's normal for a QT interval. So the QT interval is usually less than 0.44 seconds, but it's dependent on heart rate. And so if a really high heart rate, you have to adjust that number. A very low heart rate, you have to adjust that number. QT intervals are very important for a disease known as sudden cardiac death, in which a person can die. And if you have a prolonged or a long QT interval, it is a setup or potentially part of that pathology. Okay, so we have the 3 standard limb leads, 1, 2, and 3. Standard limb lead 1 is taking a picture across the heart in this direction. So if we're taking a picture across, we know we have to have 2 poles. In the right side, we're going to have a negative pole, and the left side, we're going to have a positive pole. This picture then is taken in this direction. Standard limb lead 2 goes from a negative pole on this side to a positive pole down here. And that takes a picture across the heart. And then finally we have standard limb lead 3, which has a negative pole up top and then a positive pole down here at the bottom, taking a picture this way across the heart. Having multiple ways to view the heart gives you all the pictures in this angle. Now, besides those, we have some supplemental leads across those particular plane. And these are called augmented leads. A little bit harder to think about. We have AVL, AVF, and AVR. They have a negative pole in the central terminal, which is a mathematical denotation of where the negative pole is. The positive pole is wherever you have the travel to. So AVL will be here, AVR here, AVF down here, all traveling from a negative central pole. Gives you 3 more views of the heart. So if we look at this plane here, we're getting 6 different pictures across the various leads. This is very handy because we might have pathology in 1 or 2 of the leads and not in the others, because we have the right picture for the right pathology. Okay, you also have a few other leads that are located along the chest, and these chest leads take a picture through the chest. So now you're going from the surface of the skin into the heart. And those pictures are done with V1 through V6. And how these are set up is you have to count intercostal spaces. So I'm sure you can do this at home. While you're watching right now, I want you to feel for the spaces in between your ribs. If you feel for the first space, count down 4 spaces, and that's where you put the electrode 1 on the right side. Then you have the V2, 4th intercostal space down on the left side. Then you go mid-clavicular, so you take your clavicle, split it in half, you drop down to the 5th intercostal space, and that's where you put V4. V3 you put in the midpoint between 2 and 4. Then you keep going along the intercostal space, number 5, all the way to the axilla, and that's where you get V5 and V6. So you have to count your intercostal spaces. Don't giggle. Don't giggle, don't tickle yourself, just make sure you count those intercostal spaces. Now that you have these various views of the heart, let's look at an example. So this is looking at the standard limb lead 1, 2, and 3. This is the very same heartbeat. Let me say that again. This is the very same heartbeat, looking at it from 3 different angles. You see in standard limb lead 1, you see a P wave, but the QRS complex is lower. So you really only see the R wave. In standard limb lead 2, you see the P wave and you see an exaggerated or really tall R wave. In standard limb lead 3, you see the P wave and you see a moderate R wave. This is all the very same heartbeat. Just you're looking at it from 3 different angles because you have 3 different setups of where the positive and where the negative electrode are. So in the first one, you're taking a picture across the heart here along this line. The second one, you're taking it down across the chest. And then the third one, you're taking it from here down. So 3 different pictures give you 3 different R wave amplitudes in the same beat. You might ask, well, why do you do that? Because again, different pathologies show up more often in different leads. So you have to know what a normal lead would look like in these 3 standard limb leads. Let's look at some of the other leads because they too can tell you about where the different pathologies or mean electrical axis might lie. This is the normal tracing that's going to happen through your augmented leads. And these are the ones that have the central terminal of negative and you have the positives out on one of the sides of the shoulders or down at your foot. So if you look at AVR, you can see that the P wave is negative, you see an exaggerated S wave, and you see the T is inverted. AVL, you can see a small P wave, you can see an upward and downward deflection of the QRS complex and a T wave. And AVF, you see a P wave, you see a very tall R wave, a little teeny S wave, and then a T wave. These are all the same heartbeat. That is the same heartbeat if you look at it in 3 different ways. That is why it's important to have a good feel of which electrode you're looking at so that you know what's normal. Because if all you saw was an AVR there, you'd say, wow, it looks like we just flipped our electrodes around. Or you might think, maybe the heart always generates just a negative deflection on the ECG, and that would not be correct. You have to know where you're at to know which electrode to look at so that you can understand what the ECG is telling you.